Hey friends, I'm Andrew. This is Code Gets Creative. This is part 5 of our series on light blocks. And a lot has changed since the last stream. I did a bunch of work to kind of get stuff ready for this week and to get stuff ready for publishing in the future. So maybe the best thing we could do is like catch up on kind of where the project is at now, what it does, and then what we wanted to do for this session. It'd be cool. Let's dive right into it. So I've got my Lightblocks editor open. Well, let me make that bigger. Okay. And you might notice right off the bat, if you've been watching, that some things are already different. So we've got our program here. We've got Lightblocks, right? And you'll notice right next to it, we've got this like block runner 2049. Like, what is that about? And then there's the run button. But then we've got all these blocks that are organized by their category. These are the things that we made last time, right? So now we can do conditionals, we can do control flow, we can do these loops. So I guess if we wanted to, we could like tweak this a little bit. Say 3 times. Cool. And then when I hit run, you're going to see this light back here. Follow the program. Green light on. Blue and then red. Blue and then red. And once more blue and red. And then it turns off. Sweet. That's how that works. You'll notice that there's this like thing up here. That is the name of a program. You'll also notice up here in the URL bar, we've got, /programs/2. So there is suddenly a homepage to Lightblocks. And this is kind of a listing page of all your different programs. And then let's open this up. You can see that this is actually designed to be responsive. Here's what it looks on an iPhone. Here's what it looks like on an iPhone, etc. And so you can actually just hit the home page right here and hit run on block runner 2049. It'll run through your program without even going into the editor and looking at Blockly. And that's cool because my hypothesis anyway is that when you'll make these programs in kind of one like deep workflow, you'll get them just right. And then you'll kind of leave them there and you'll run them when you want and you'll enjoy them. But those are kind of 2 different experiences. And so being able to really easily run them from just this control panel, kind of listings page, will be really nice. And remember that eventually the plan is to get this whole thing to run on a Raspberry Pi computer. This is a Raspberry Pi 4. And we're going to be focused on that a bunch next time. So tune in. Stay tuned. So in order to power all this, there are operations to create a program, to edit them, to delete them, to run them, etc. So that's now in place. I don't think we need to go super deep into it. You can check out the code on GitHub, of course. But the thing that I want to do today is actually related to controlling the lights themselves. So when I run this program, notice how this light turns on and does all the cool things. I'm gonna turn it off actually. But I've got the second light behind me. Here, we'll switch back to this. I've got the second light behind me and it's not doing anything. And actually I've got 4 of these Philips Hue lights in my house. And so far, this cool app that we've made is only able to control 1 at a time. And so today is going to be all about actually changing the control so that we're not just controlling 1 at a time, we're controlling all of them. And that brings us, so that's exciting. But that brings us to all sorts of questions. If we know we want that, like what are the use cases we need to support? And what are the trade-offs with designing blocks that will let us do this in different ways? So what I've got here is my little idea journal, or my like project notebook. It's kind of fun. This is like a bunch of different Pantone colors. Picked this up in Seattle when I was visiting one time. And I've got all sorts of cool like app ideas and designing some generative art right here. What else? Here's like designing a chatbot for something. What else do I have? Some static analysis, doing like writing programs to read other programs. Here's the synth transformer box. This is like picture number 1 that I drew in order to start planning that. That's pretty cool. But over this last week, I had kind of a long plane flight. I was going to visit some relatives, flew on a plane for several hours, and so I had some time to sit down and think about this idea of multiple lights and how to tackle that. And so here's what I did. I opened up to a blank page and I started to draw. You'll notice I've got like 2021-07, so I can remember the month that I did this, light blocks. And then, let's see, I think I was irresponsible and I just started kind of drawing at the beginning. But then I quickly realized that I needed to plan a little bit more. And so I wrote out some use cases and I talked through these use cases with my wife, and she was really helpful in thinking through kind of how she might use it, how she might think about it as a non-programmer. And so that was really useful. And eventually we landed on, let me make sure, yeah, that's unrelated. We've also, I need to show her work right here, but we've got this like beautiful plesiosaur dinosaur thing going on right here. But yeah, let's see. Notice here, we've got our starting block. So when the program starts, do something. And we already recognize that. Then there's the second block, right down here, set control to all lights. I decided to scrap that. And instead, planning on doing these other like blocks that have statement inputs inside of them, right? Just like these. The reason for that is basically trade-offs that have to do with explaining control flow. So let's, here, I'm going to go back into the screen. Let's say that we're editing, whoops. Yeah, let's say that we're editing this program. And by the way, let's turn the light off, yeah? There we go, we got the light off. So when you're editing this program, you're thinking about control flow, it's all step by step and it's one thing at a time. And so we start here, we go to loop, but then immediately we're gonna drop down into here, right? Now we're here, 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 here. But you can't really have two things going at the same time. Like the Blockly and Scratch paradigm doesn't really allow for that. And so we don't even say that loop 3 times do is the current block. We basically pretend that that is never the current block, and we go straight to one of these child blocks in the sequence here. And that's important because what if you actually have multiple things going at the same time? How do you express that? That comes with one of the use cases. So let's jump back over to here. I've got my use cases written over here. Let me kind of read them off. So I think use case number 1 is control all the lights together. So we've got light number 1, we've got light number 2. We want them both to do the same thing at the same time. So when we say set color to blue, they both turn blue right at the same time. Or turn the light off, they both turn off at the same time, etc. The next one is control each light with its own logic. So that's like tell light number 1 to turn red and blue, tell light number 2, I already switched light 1 and 2, whatever, you get the idea. Tell this light to be red and blue, tell this light to be yellow and green. And so there's a chunk of logic that this light is running, and it's totally isolated from the logic that we've snapped into place for this light. So that's another use case. And then there's a third use case, which is run the same logic in a different runtime for each light. And what I mean by that, this is kind of abstract, but I'm very excited about it, is basically, let me switch back over to here. Let's say that I drop in a wait block right here. And I'm going to say wait for a random amount of time. So we'll do this. And we'll say, I don't know, between like 1 and 5 seconds. Something like that. So let's say that we've got that like snapped into here. Now, suppose that this loop ran totally independently or isolated for these two lights. What that means is that we're going to evaluate this block, the randomness block, once for each of these. And so they might end up with different numbers for that random value. And so now they're going to kind of go out of phase with each other. And maybe this one is a short amount of time. And so it'll very quickly go from blue to red. But then this one is going to wait a little longer. And I'll stay blue for longer. And then finally go to red. At which point maybe this light has already moved on. And it's going to go do the next thing. The other thing is that, where is it? Remember that we can say set the color to a color from components, and maybe we say that the hue is anywhere between 0 and 359, right? So the entire color wheel around. Well, now if we snap this into place, then each of these lights might pick a totally different color from each other. And so we've now got like a much more kind of dynamic ecosystem of like a whole room of ambient lights that are all kind of morphing independently of each other. And I think it's going to be really magical. And it's going to be a lot more interesting, I think, than make every light turn red, make every light turn blue, or even make every light turn random color. Because now we've got this like kind of evolving, shifting thing. It's going to be really cool. And I'm going to prove it to you on today's stream. So let's talk about the blocks that'll actually make that happen. There's 3 use cases, right? So make all the blocks, or make all the lights do the same thing at the same time. Have totally isolated logic, so different blocks for different lights. And then we've got the same blocks for different lights, but they get run independently from each other. So, okay, 3 use cases. That means we need to be able to express those 3 different options in a way that's going to make sense to the user, the programmer. So here's what I'm thinking. That first use case should be the default. That's the one that is kind of the most intuitive. It's like, oh yeah, I have all these lights. They're all connected to the internet. They should all do the same thing. And so if you don't use any of my special blocks, then this logic should now control both of these lights. That'll be the default. Then option number two is going to look like this block here. Okay, let's switch back to the camera. It's going to look like this. So notice how it's like start logic for each light. So then, let's see, light 1 is going to do whatever you plug into there. And then light 2 is going to do whatever you plug into there. And you see this like plus sign. We could have, start with 2, add some more, remove them, whatever. I think for today's session, we can just say like 1 through 4, because when you buy Philips Hue lights in a pack, they come in 4. So let's do like 1, 2, 3, 4. And you could just leave some of these blank, in which case nothing will happen, right? It won't send any instructions. But yeah, then it'll do the thing. So that's use case number 2, right? Where we've got different blocks for different lights. But then that third use case where we've got same blocks, different runtime for different lights. I'm thinking something like this, where it says run logic independently for each light, and then do whatever this sequence is. And then eventually, and in Node.js land, this is a promise.all. We just say like, for every light, run this logic, right? And await that logic. And then eventually all of them are going to finish. Potentially, if there's no like loop forever, right? There could be a loop forever, or if false loop, that kind of stuff. But basically, there's a case where they all finish at different times, and then there is a bottom connection right here so that we can go on to other stuff if we wanted to. And that way, I don't know if people use it or not. Like, the use cases that I have in mind are probably like drop a loop forever block immediately inside of here, and I think that'll be really cool. But there might be other really cool use cases where you snap something below here. There's a little intro thing that's really magical, and then boom, everything does the same thing. Maybe. And besides that, this just kind of fits into the ecosystem. You know what I mean? Like this is the way that the other blocks behave. And so we want to have like a consistent kind of interface for everything. So that's our plan. We got 3 use cases, and then we've got the default plus these 2 new blocks. So today's stream is all about designing these 2 blocks and then implementing them on the front end and the back end so that we can actually control both of these. Let's do it. So let's do this first use case number 1 first. Back to my screen, and actually let's write this out. So use case 1, all lights follow the same logic. Good. And then we got use case 2, which is each light has its own logic. And then use case 3 is all lights follow the same logic in different runtimes. My favorite. Okay, so let's tackle this guy first. Oh, I'm gonna make the text 1 click bigger. There we go. So we've got our 3 use cases. Let's do it. So in order to do that, there's no changes to the blocks themselves. Front end is done. So let's go over to the back end. We've got our interpreter, and you will notice that the interpreter has a reference to an environment. And whenever we say set color, here's the set color block. You'll notice that what we do is we evaluate what the color should be, so we know that there's a hue, saturation, brightness. And then we get the environment from inside of the interpreter, and we call set color on it. And so this environment right here does all of the work to actually talk to Philips Hue. So let's look at that for a minute. That's where our first edit is going to happen. So let's see. We've got here's set color. We've also got light on, light off. So we've got hue, saturation, and brightness. Oh, did I? Hue, brightness, saturation. Oh, friends, I think we just caught a bug. Hue, brightness, saturation. I think HSB, it should actually be the other way around. I want it to be written like this. HSB and then how are we calling it from here? HSB. Yeah. Yikes. Okay, well good. I'm glad that we caught this now. Okay, so we set the color. And then notice how we say this dot client is our Philips Hue client. Dot lights dot set light state. Yeah. We get the light ID. And here's what we tell it to do. You'll notice that there's a premise.all that wraps around it. That's because I noticed that either it was Philips Hue or it was the library wrapped around it, was actually not waiting for these to complete before resolving itself, like its own promise. So what this is saying is like, hey, start that command to set the light to this new state, but also pause the same amount of time, right? So even if this happens to return early or resolve early, this is still going to block. And so this outer promise that set color returns is not going to resolve until it's time. So that's cool. So what we need to do is say set light state for all lights at the same time. In order to do that, we need to figure out, like, does this library let us change that all at the same time? Or are we going to have to, like, do a promise.all for every light or something like that? And let's see, this comes from the light ID in the environment. Okay. Which we can remove as soon as we implement this stuff. So let's go look up the docs for that. So we need the servers package, and this is Node Hue API. It was version 5. Okay. Yeah. So we're on the latest. And let's see, we've got a light state object. Now I think, oh yeah, this internally creates a light state. That's what that's about. So I think we actually want to look at lights. We've got, okay, so we've got get all. Allows you to get all the lights that the Hue bridge has registered with it. Okay. And then how about set light state is used to set the state of a light specified by the ID to the specified state provided. What I'm noticing here, like, I think they only have commands for a single light at a time. Get new, search for new. I think so. Now, there is this concept of a group. So maybe we should check that out really quick. There's like groups and scenes. So let's have a look at that. The Scenes API interacts with specific scene objects stored in the Hue bridge. Oh, these are not to be confused with the preset scenes that are present. Oops. So these are stored in the Hue bridge. Concentrate. Okay. Oh, and look at this. It's like... So even this one, like update light state, it's still like update for this one, for the scene to update. Oh no, maybe that would work actually. This is like scene ID, set all of the, but yeah, okay, light ID comes next. So I mean, even this, like even if we try to get real fancy and like synchronized scenes with Philips Hue, we would still have to control one light at a time. Huh. How about groups? Display the groups from the bridge. Group by name. Create group. So here's how you create one. Get group state. Okay, here's set group state. So we could say like, take this whole group of lights, turn the lights on. Okay, so this could work. This could definitely work. Oh, and then what is this? Oops. New group light state. For that scene, I guess. The set group state function, as detailed above, is the function that needs to be used to activate or recall an existing scene that is stored in the Hue bridge and lights. Okay, so but we don't care about scenes because we're doing dynamic stuff, not static scenes that they have. Okay, so now we've got to decide: are we going to use set group state and like create a group and then set its state, or are we gonna kind of roll this ourselves? Well, how hard is it to create a group? Create a group. Okay, looks like we start from that. Give it a name, tell it which lights, and we can figure out which lights based on the reachable lights. So that should work. We create the group. Yeah. And let's see, we can give it a name, and then I think we can get by the group name. You can say like, get my group. Oh, and then, okay. It'll return matches. Group names are not guaranteed to be unique in the Hue bridge. Yeah. Let's do it. I think we can totally do this. So here's what I think we should do. We need to get or create a group for light blocks. And that should be like all the reachable, whatever it's called, all the reachable lights. And once we've got them, we should be able to interact with that whole thing. I'm gonna start by doing this. So then I'm gonna say, let's see, we connect to it. And then right here, we want to do like get or create light group. And this will be like, I'm thinking we should hold a reference to it. And I'm not sure how this is going to be namespaced in here. It took a little bit of digging to find this. It's going to be a group object. So where is group defined? Model. Hue bridge model. Look at that. It's in this like private package. But I think that you can actually. Yeah, here's model, and then here's group. Declare class group. Extends that. Yeah, that's the one we care about. Is that how you write that? Maybe not. No. Let's write it this way. So say model.group or null. And it doesn't like that. Oh, okay. So now we've initialized it. And then when we initialize the environment, we'll need to await that. And this is going to return a model.group or null. Could return null. So now at this point, let's see, we're gonna check and let's call it like light blocks v1 or something like that. Group name. And then if it exists, return it. If not, create and return it. Now, why is this complaining? Oh, yes, that is true. Okay, so we are returning a promise of that type. Okay. I like that. You'll notice that these are still broken. And actually, you'll notice also that we're still going to have set color to whatever, and we'll still need to be able to do that. But now it's going to become contextual. And so we're going to have to do something like check which use case we are in. And we'll be able to do that and set the environment the correct way. Maybe even pass it into light on. We'll see. Eat some party peanuts. But in the meantime, let's see. We need to figure out how to do that. API.groups. So this dot client. Wait. I'm gonna call set group state. Oh, look, and we just need an ID or group object. Yeah, I like that better. Like, I think we can keep that reference to the group. And if we make it this far, we know it's going to be there. The type Boolean is not assignable to type. What's going on? Have a problem with that? Does it want... Let's see, I see it returns a promise, that's fine. It's a group light state. How about we do... So here's what that used to be. Oh, it really wants that to be a model.group state. So Let's see, how do we create a group state? Let me make a group light state. There it is. Oh, right there. In addition to the common properties for a light state, it also has that. So we should be able to use all the same functions. Okay. So we should be able to say .on. Is there a transition time? Looks like these links are broken. The transition value function was that in milliseconds. Yeah, so I think that's our new state. And I'm willing to part with this now. Whoops, let's paste there. And now let's copy that over to here. Whoops. Let's just grab we make a new state. This will be .off. We'll do that to the new state and get rid of this. Okay. And then set color is going to be a little different. Oh, hey. This is my chance to fix a bug that's been around for a little bit. If you call set color, but you haven't included turn the light on first, it'll actually explode. It'll throw an error and everything. So we're gonna fix this right here. We're just gonna say, if you're calling set color, you also want to turn it on. So that's great. Okay, so we want to turn it on, and then we want to call hue, brightness, saturation. I saw, where was it? There was like an HSB function. Yeah. Oh, hey. What about, where is hue? So one thing that I am noticing is that if we call hue directly, it's actually, like, the resolution is higher, and we're already doing the math. Oh, and this one. Shoot, this doesn't quite map over the way that we wanted it to. So yeah, maybe we should just make the transition. Like we can drop a little bit of resolution. I'm cool with that. Typo looks like they're solving for it. Okay, so let's just call HSB. .hsb, and then we're gonna pass in the hue from 0 to 360, saturation, brightness. It doesn't exist? Look at that. That's dumb. Okay, well fine. Do you have Hue? Yeah, okay, let's switch to those. We'll use them after all. We'll have to do a little bit of scaling. So here's saturation 0 to 100. And then what about brightness is 0 to 100. So this will be hue scaled, right? This hue takes in this real big number. Yeah, okay. Looks right. And then we should be able to grab this. And look at that. Set light state for all. Oh yeah, we added that today. So we're handling this, and then we've got our 3 things that we change, plus writing dot on. Okay. That's cool. The only thing we have to do now is actually implement this function, or else none of this will work. So let's see. So we need to check if this light group exists. Let's go back over to here. Say get group by name. This dot client bang dot groups dot get group by name. Group name. So this will be possible groups, you know? And we need to await this. And then take a drink of water. Then we'll say found group. We'll say possible groups dot find group dot name is strictly equal to group name. Now we can just keep it undefined. That's cool. If we found the group, then we'll return it. Okay. Else we will create it and then return it. So let's see, here's how we create one. And that returns a created group. We already have model in. Oh, what? Create group. Not create group scene. No, no, no. Huh. No, it's model. No. Oh, okay. Well, yeah, I mean, shouldn't this work? This is oh no, it's the model that's nested under that. I kind of think this is a a typing error in their library. Okay, but that's fine. So we'll say const group equals create a light group. And then the name of it is going to be group name. And then we need to figure out which lights to put in it. That's right. So we need to get all the lights. Get all. And I think it doesn't, we probably don't even need to like filter it out by just the available, because we can set the whole group to something, and if something in the group is like not available, then it'll just do nothing. So this will be this.client bang lights.getAll. We need to await that. Let's put that up here to kind of clarify like sequence. And then right here we can say lights.map. Yeah. Bridge object ID. Oh, does it? I wonder if it just wants this then. No? Wait, it wants a... Oh, it wants some strings. Okay. That's kind of weird. So here's an easy way to cast it. And now we should be able to say this.client bang.groups.create. And let's maybe call this like group settings. Created a group. We create the group with those settings. And so then we should be able to say return created group dot ID. Oh no, just kidding. We're going to return a group or null. So we can actually, sorry, skip around. We can just say return create group. Okay. We get group by name. We try to find it. If we found it, we'll return it. Otherwise, we'll get all the lights. We'll make the settings for a group with that name, with those lights. We'll create the group and then we'll return it. Yeah. That all sounds right. I would like some logging in here. There we go. Yeah, I think that looks good. And then we've already done this. I think we're ready to go. We should try this. Let me check a thing real quick. This real fast. I'm just checking stream settings right now. Okay, cool. So that is running now. And now we should be able to run back over to the app. Okay, and if this works correctly, we should see both of these lights do the same thing. Oh, hey, we should also see this. And if we restart it, we'll wait for a little bit. It'll recompile again. It found the existing light group. Good. So that logic is working, so we can tell. Now if I hit run. Oh, yeah. Nice. Let's do that one more time. Yeah, okay. I think there's some quirks to it, like they don't change it exactly at the same time. So we may actually, like, I think what we're seeing is that the this default transition time might not be enough actually. Like we got to add like a little bit of buffer time so that we maybe we say like 90% of that time. Like the lights should use 90% of that time. We'll wait an extra 10%, but then with just a little bit of network lag while the bridge is like you start, then you start, we'll be able to kind of account for that. I think that's something that we can fine tune later. We don't have to worry about it yet. The other thing though is I don't think these are full brightness. No, maybe they are. I think they are, yeah. I think we're good. Cool. All right. Well, I think this is a commit. Let's get this gathered up. So we say save the group. And then we say, here, let's split this. No longer save the light. Getter create the light group. Light on, light off, set color. Yeah, awesome. Say control all lights together. Okay, that's been pushed. And I'm going to mark that off. Love it. Okay, so now let's do this use case number 2. This is where it starts to get real crazy. Each light has its own logic. And that got pushed, yeah. Okay, so let's do the front end first and actually design the shape of the block. I think we can put them in here. Should look good. We could put them in here, but I think like this should just be colors. Yeah, let's put it in control. So we want to open up UI blocks. Got all this logic and stuff. Yeah, here are the loops. Let's put them below that. So let's just like copy this bad boy. And let's see, we need to give this a name. It belongs to control flow. So we could call it control. I don't know. we could call like distinct logic. So the other thing is that in computing, we would talk in terms of like threads or processes, right? Like if we want to split our program so that multiple things are happening concurrently, those are like the primitives that exist in real programming languages. There's like threads and processes. And even like processes or threads can mean something different depending on your programming language. Like I work in a language called Elixir that's built on top of the Erlang virtual machine. And in that, like a process is this very lightweight thing, whereas like at an operating system level, it's a little bit heavier, and scheduling treats it as this larger unit. What does that have to do with light blocks? I don't know. I don't think it does. Maybe what this means, though, we can namespace it as processes. And this is only like a machine-readable slug here. I don't think we're going to say this to the user. It's like processes distinct. So this is processes distinct. Yeah, let's even just process distinct. Run distinct processes. So now run is the category, basically. Let's do that for now. I like that. Okay, so let's we're gonna run over to our notebook. Run logic independently. No. Start logic for each light. Or probably run logic for each light. Run logic for each light. Okay. And then we want to say block.append statement input. And this should be like yeah, we'll have a bunch of those. And we need to like append field, right? And this will be light 1. Let's find out if this is formatted correctly at all. Oh, we also need to add this to the toolbox. Run distinct. Is that what I called it? This is probably an indication that it's a bad name. But let's hit refresh. There it is. Yeah, okay, so that's shaped correctly. At least for light 1 it is. And through the magic of copy paste, we have 4 of these. 1, 2, 3, 4. Yeah, I like it. And then I want to change its color. What if we actually do this as like yellow? Is that yellow? It is. Oh, that looks really ugly in Blockly's color palette. Eventually, we are going to steal the color palette from scratch, probably, because it just looks so good. Like, as soon as this guy loads, like, look at how warm and friendly this feels. Like, it's like bubblegum colors, you know? Whereas this is like kind of drab and kind of gloomy. So I'm excited to get to this, where we've got these like bright, saturated colors that are really like kid-friendly and feel welcoming and all that good stuff. In the meantime, I I need to be able to live with this color. How does this look? Do you have any more? Yeah, we've got this color green. This shade of green. I don't know. What does this look like? Kind of orange? I think the orange looks okay. We're gonna have to go back and like change all this color palette. Whatever. Let's do this one for now. I think that should be good. Okay. So we're gonna run the logic for each light. We got our front end, now we need to define the back end. Make sure, yeah, we got a top connection and a bottom connection. And let's actually, boom. We'll create a special test just for this. So how about we do this? I think, so I'm going off memory here, but I believe, I think this is light 3 and this is light 2. We'll find out in a minute. But let's do, I don't know, let's say like wait for 3 seconds and wait for 2 seconds. And then we're going to turn the light off, which now that we're outside of this block, the context changes and we'll be running for every block. So every block will turn off. Ooh, which actually might be a really good like test. We will, I don't know, we'll set the light to white. And then let's wait for just 1 second. Yeah, set everything to white, wait for a second, fork the processes, and then join them, turn the light off. Okay. So now we need to define this block on the back end. Make some stuff down. We're gonna be in here. Another thing that I did in between streams was move all this stuff into categories. So yeah, things are getting more organized. We're gonna do something kind of similar to this. This might be a good starting point. Run distinct processes block. Be that. And then evaluate it. It'll be like light 1 sequence, or maybe like sequence light 1. Science. Now, if any of these are blank, that's totally fine. So we don't want to have this kind of logic. But I think what we do want to do, we need to group them all, run promise.all on them. Sequences. And let's see, these can either be null or an element. Yeah. Okay. That looks kind of silly, doesn't it? Should we just put them right in here? Yeah, we do that. YOLO. We've got our 4 sequences. And then we should be able to... Yeah, that's sequences. Sequences.map. And I'm going to need an index. And we're going to say if there's a sequence, then let's see. Okay, so we need to return a promise for this. Else we need to return promise.resolve. And the other thing that we need to do is we need to say light ID equals IDX plus 1. So this is 1, 2, 3, 4. And we need to be able to pass that into here, like execute this sequence, but do it only for this light ID. Getting tricky. All right, well, let's add that here. And I think what we want to do is light ID can either be a number or null, but we're going to default it to null. And that's kind of going to cascade into here. And right here. Param light ID. Yeah. Okay, so we've got it documented. There's another interesting problem that we're about to see here, which is that we can't really set current block for multiple things. So we can't be like current. It's just like it's going to turn into a mess. So I think we should actually say if there's no light ID, then emit that event. But I would like to see this statement. Okay. Well, okay, so this is... we're gonna have an inversion of control problem here real soon. What I mean by that, yeah, I mean not necessarily. We can decide. So let's open some code side by side. On our left, we've got like run distinct processes block. This doesn't know anything about the light ID because it starts out running them for all, and then eventually it calls into something else that's going to execute it for just one at a time. But by the time we get down to here, set color block, this guy right here needs to know, am I running this for all lights or just for one light? And what we really need is like a proper. We need like an execution context or environment that is isolated, and that would basically get passed into here, and it would it would be some kind of object that would include light ID. It's probably number or null. And then we call that on set get environment. Yeah, the thing is, like, maybe it should just know. Well, I don't know, because here's where we call this dot evaluate. Let's move this over here now. So when we execute a block, we say evaluate that block, which then will evaluate everything that's nested underneath it. And so we get the handler, and then we call evaluate on that handler. We need to pass in some stuff. We need a reference to the interpreter because we have to be able to evaluate sub-expressions. We could pass around a context. Interesting stuff. Yeah, I think we want to pass around. We want to pass around a context. All right, let's invent one. Program meta, amazing. Oh, this is an interface. And let's see, this is actually just gonna have a light ID, which is a number or null. And eventually this is gonna have variables, which will be like var name is a string, and it's gonna point to a program value, and it'll be awesome. But we're not there yet. That will come later. Okay, so then are we going to nest the interpreter inside the context or not? I think it might be a good idea to. this is growing ever larger. But then again, like environment, this is basically like the native functions. So it's kind of nice having it like very isolated. Yeah, so let's, what do I want to do with it? Let's maybe add it as a third param. I think that's a good idea. Okay, so yeah, let's save that here. When we call evaluate, we need to create a context. Oh, what have I done? There we go. Got our execution context, we pass it into there. And this will be the execution. Yeah, I think we can just leave it at that. We'll pass that in. And we're gonna have to change this as well. Evaluate the sub-expression with the context. Okay, and then every handler needs to update. This is getting real long. Later on we'll add prettier. Maybe I've already said that in previous streams, but we should actually do it. Okay, we've done that. And now this is an execution context. And evaluate sub-expression, that goes on the end. Yes. Okay. Now this is great. We've now broken everything. Each of these blocks needs to be updated to accept an execution context. Let's here, we'll turn all these red. Oh, it's not doing it. Context is an execution context. Pass in the context. Pass in the context. Pass in the context. And you'll notice that, like, a lot of these, I guess this one needs it just to pass it through, but like this one doesn't actually touch the context. It's just like gathering up some stuff. Whereas this one, it needs it. And here's what I'm gonna do. Oh man, I kind of... What I'm thinking is, like, do we make two functions for this, or do we have a function with an argument? I like how simple this reads. So that's cool. And I think having fewer functions here probably makes it easier to understand, like, what can be done. So let's do that, yeah. So we're going to say light ID is a number or null. And then we basically have, like, if there's a light ID, treat it one way, else treat it the other way. And we've gone and thrown away our other implementation, which is too bad. Light state, is that a thing? It is, okay. Set light state, and then this should be light ID. Yeah. So that's not all that different. I like that. There's some duplication obviously, but I think it's easy enough to read, and it simplifies it on the caller side. So cool. Light on. Pass that into light on. And we're now doing what to do. So if there's a light ID, also, we need to say that this is a promise of void. Is it not like that? I guess really we just want promise of any. Or promise of unknown is that's the more defensive way to write it. Promise of unknown. So then right here, this is a light state. Lights, set light state. Light ID for that new state. Okay, so that's implemented. Let's close out some of this stuff. Got to really save some real estate here. Context is execution context. Okay. Context is execution context. Context. Oh, whoops, that doesn't go there. Look at that. Okay, I think we might have made a mistake earlier where we've got interpreter and we're saying execute with just this light ID. I think what we actually should be saying is start from this context. And then right here, we should be creating a context where the light ID is empty. So let's actually make that change now. To run the sequence within. Yeah, I'm glad we caught that, because I think that's going to be a better design. So then we should be able to say if not context.lightID. But then we don't need this anymore because we already have a context. Oh, yeah. Okay. That looks good. Then right here, this is where we're calling run. And the initial context is going to be execution context, where the light ID is null, meaning we're controlling everything together. And remember, we're setting this up so that eventually we can have variables and functions and all that cool stuff. So right now it feels kind of empty, but it's going to be really nice having this context created the way that it is, and then we'll end up like cloning contexts and putting extra stuff into them. Sorry. Knocked my glass against the thing. Okay, so now we can say execute that sequence with that context. Yes. And then we can do the same thing here. Yeah, this is coming together. Pass the context in wherever it needs it. Oh yeah, cool. And then this part right here, we're gonna say like inner context. So I'm cloning the context, whatever that may be, right? But then we can say light ID is equal to the new light ID. And maybe we'll just do that. I think it's more correct to say child context. Okay. And then we've got a start block. This will take any context. Yeah. Okay, so we made it through these two. Let's see, this is a... Now, this part's kind of tedious, obviously, but you can probably see how like we're laying all this groundwork, and I think this is all just going to run like once we've got context passed around. So as soon as we get all that stuff updated, I'm very excited to run this thing. And we kind of front-loaded the decision making for this. Okay, that's 3 done. That's 4 done. And last but not least, here's timing. Okay, I think we've updated all of our blocks. So now the fun part. We'll see if it compiles. Okay, everything compiles. Hold on just a sec. I have to respond to a text message. All right. So now we should be able to come back over here. I want to see this. I want to see this. Woo! I'm excited and nervous. I think it'll work though. What just happened? We killed it. Okay. Set color, not a number, 0, 100. Well, that's weird. What's going on over here? Oh, so hold on, we never implemented... Like, set color is not actually taking in a light ID. Do you want it before or after? Let's do it before. Okay. And then we'll say if there's a light ID. And actually we can move some of this stuff out here. We know the drill. Set light state. There should be lights. And this should be light ID. Okay, so I mean that's caught up now. Now I'm ready to pay attention to the error. So let's see. We called start, and then we called set color. Why did we do that right after that? Oh, because that is actually okay. Okay. I wonder if the issue is actually with that shade that we chose. The color picker that we're using right now is kind of temporary, and I think we need to replace it. So yeah, I'm totally willing to, like, let's set it to green first. You bet. Okay, here we go. Refresh. Yeah, it's still there. Run. Oh. Okay, what happened here? I think we crashed. Oh, there's no handler defined. What do you know? Where do we do that? Yeah, here it is. Run distinct processes block. QRS, yeah. So it's alphabetized. And then we'll run that again. There we go. Holy smokes. It worked. We did it. Yes. I want to make it really obvious that that the timings are different. Maybe I'll like double this. So here we go. Run. Everything turns green. That dims first. Then that dims. Then they both turn off. Perfect. So it works. Oh yeah. I feel very good about that. Yeah. Very cool. Just checking stream stuff again. Okay. Yeah, I think we should clean this up and commit it. We touched all the files, so that's good. So let's see, light on, light off, set color, execution context. Yep, this is all the interpreter stuff. Yep. We're updating all the blocks ever right in here. More blocks, more context, all the context. Yep, we're still going. We define the block on the front end. And then here's the new file. Yeah, so everything was expected there. So let's see, this is add block to run distinct processes. Sweet. Okay. So we've now done use case number 2. Now we're on to my favorite, use case number 3. And I think we have laid all the groundwork to make this pretty easy, actually. So yeah, let's give this a try. Let's start on the front end. So let's see, we've got UI/blocks. So what are we going to call this? We've got run distinct processes, but we've also got like run duplicate processes. Yeah, I like that. Okay. And then let's see, how did I word this? Run logic independently for each light. Dependency, yeah. I think it needs to be like run the same logic. And then this is going to say do. Okay. And then we need to put it in the toolbox. Right, duplicate, yeah. Do I want it before or after? I think this one's my favorite, so it gets to go higher than distinct. But it's alphabetized below. All right. So now we've got our test. And here it is. And what do we want to do? How about we can like blink the lights on and off? I think that should, well. And let's like loop it a few times. And we gotta be consistent about our colors. It's a nice red color. But then we need something that's gonna make the execution different. Oh, let's do like between 2 and 4 seconds. Maybe we should even like... Yeah, I think this will be fine. We'll probably be able to see it pretty easily. Okay. We've got our front end. It's all figured out. If I hit refresh, that has saved. I'm loving the like saving and loading programs. That's working so great. So now, under control, once again, I call this run duplicate processes block. Let's copy paste it from this guy. Duplicate processes. And we need to define it on the back end. Okay. Or we need to like add it to our handlers. So that's done. So now let's just say sequence is gonna be this. If there's not a sequence, what do we do? Do we throw? I'm starting to think more and more that like, well, maybe not with that one, but like, well, maybe. I don't know. Basically, it should be okay to have something blank. Yeah, in either of these, it should be just fine. And so I think we want to stop doing like, if the sequence isn't there, then throw. I think really what we want to do is just return early. But now what we need to do, and I think our context isn't ready to do this yet, but we can add it for sure. So let's ready to do get each light ID, and then for each light ID, run the sequence. And that's going to be wrapped in a promise.all. And then execute each one in parallel. There. Okay, so how are we going to get our light IDs? I think they could, well, so they could come from the context. We could like save them in as we create it. The thing is like, as we get deeper into a context, it doesn't really care what the other light IDs are. It only cares about its own. So maybe that should just be part of the interpreter. Like the interpreter can tell us, or really like the interpreter's environment will tell us. So let's, the thing I just noticed is I want this to be private. I'm going to move it down here, and I'm going to say private async get or create light. Okay. But then I should be able to say get light IDs, and that's going to return a bunch of numbers. And I think we'll just start with that for now. Oh, whoops, get environment dot get light IDs. Yeah, let's go ahead and implement the caller side first, and then we'll go in here. But basically, we're going to say await promise.all light IDs.map. Oh, no, we may... I think this should be like get available light IDs. The reason I say that is because if we've just got a list of like every light ID that's in the group, then we're going to end up attempting to execute sequences against light IDs that are offline, and that's going to throw, and I don't think we want to like handle that inline in each of these. We should just never execute those. Okay, so then for each of these light IDs, we're gonna say, yeah, we're gonna grab this. The child context is just gonna be light ID. Yeah, so I think that's it. Okay. And then once this is finished, which it may never finish, once it's finished, we're gonna return void. Okay, so how do we implement this guy? Get available light IDs. I think, so I think this actually, either we need to like memoize it or just cache it when we initialize, or else we need to do it here. When we hit the block, we need to call this, and this is an async function. I would rather just do it when we initialize it. So let's say available light IDs, and this is going to be a number array. Here we go. Get or create light group, and then right here we can say available light IDs equals and yeah, I think we need to call get light or get all. This dot client dot lights dot get all dot, oh, let's see. So we're going to take each of the lights, map them to their ID, but we also need to filter. Isn't that like dot available or something? I'm not sure. What is going on? Is this a string? Is this really a string? Is this real life? Okay, let's do this. You know, I probably didn't need to do that, huh? I can probably just say, like, pass in the object lights. It'll format it for me. So let's try that. We'll just let it initialize it and see what it tells us. That's interesting. It's not a module. Have we not saved it yet? Yeah, it looks like that was it. Okay. We've got... how tall is this? Also, let me just double check a thing. Okay. Here's an ID. Interesting. So let's say, like, for each of these lights, oh yeah, and then does this tell us whether it's available or not? I forgot to pay attention to that. So like here's light 4, which I think is unplugged. How can we know this? Is it like online or reachable? Yeah, I think it's reachable. Okay, does this say anything about reachable? Reachable? Is reachable? No? I guess we could get the light state for each of them. Let's see what their sample code looks like. Yeah, I think we're not. Oh, well. I mean, that could be useful. Let's just see what this says. Okay. Oh, look. So it has a state nested underneath it. So I wonder if we could just say light.state.reachable. I would really like to have reachable. Stringify light.state. I'm pretty sure this is just a typing issue again. And so if that's the case, Yeah, look at that. It's right in there. If that's the case, we're just gonna have to hack around it. So we can say reachable. Oh, maybe it won't even. Let's see. There's a TS ignore. Can I do this? Or as Boolean? Let's see. I don't want to use it for a. Ignore the line below it. I mean, yeah, that's fine. Let's do it that way. Oops. Oh, and guess what? This is actually light.state.reachable. All right, but we're getting real close. False, true, true, false. Yes, that is what I expected. Okay. So now we should be able to say lights dot filter, whoops, dot filter and let's maybe let's actually rename it so we're using the same vocabulary as them. And I think we can just collapse this into a single statement. Dot filter dot map. And is it really? It's not a number. It's a string. I thought it was. Hold on. Let's be sure. And then we'll say type of light.id. I mean, I guess we could just parse int right here. It's very silly. Good grief. Look at that, they're numbers. So, yeah, I don't even feel bad saying light.id as a number. I think I can collapse that down though. Okay, so now we've set reachable light IDs. which means this has become really easy now. And now over here, got a bunch of light IDs. For each of them, we're going to execute a sequence. I think we did it. So let's run this. I think I would like to log out. And then yeah, I think that'll look great. There we go. And now we got this bad boy. And we should watch it go out of phase. What just happened? What did it do? I think we need some logs to figure out what's going on. And I don't think we've, well, yeah, I'm not really sure what's going on. But I think we were very close. Run. Oh. So hold on, we're hitting this, but then we never hit that statement. And it's because of this. Process, let's see, what did we call it? Just process, yeah. Okay. There we go. Okay. Turn them on. Now I'm not sure what's going on. Oh, that one turned off? I think it's working, it just feels really weird. Done running duplicate processes. I think I've confused myself. Okay, how can we make this better? How about we do... We will actually create a random color. Full saturation, full brightness, random hue. I don't know, something like that. So we should see a bunch of random different colors, and they should wait different amounts of time. That's saved. And here we go. The colors to red. Different colors. That changed. I think that changed. That changed. That changed. Holy smokes. Did it finish? Yeah, it did. Wow. Can we do like 20 times? We'll just like keep this bad boy running. We're getting all sorts of different colors now. Oh, you know what we should do? Is like when we're finished, we should just turn the light off, of course. Boom. Yes. Hold on a second. Did it? Yeah, it's still going. Yes. Oh yeah. And I think it looks cool on the stream, but it's like very dramatic in real life. You've got all the colorful hues like against the white walls of the room. It creates this gradient. They're like shadows going different directions. You gotta run it again. Because you know. Yes. All the vibes ever. Unlimited randomly generated vibes. This is kind of what I had in my head. Like, I want to be able to do this kind of stuff with blocks. And it feels really cool. And yes. Oh yeah. I'm so satisfied about this. This is great. Okay, I'm gonna turn my light back on. My room light. Ah, just in time. Okay, and I think we're just about at a stopping point, so let's get this all committed. So we've got our reachable lights. Yeah, oh, that's just making it private, that's right. We define that block on the front end and the back end. And then I think I left some, yeah, I don't really want that debugging in there. What did I say for this other one? Add block to duplicate processes. Awesome. So that's in there. Let's see, as a reminder, Andrew, here's light blocks. So, yeah, the latest is up here. I should post this in the chat. Yeah. Okay, so you've got access to all that. Yeah, feel free to give it a try. And remember, the next time we stream, it's going to be all about publishing this. So we've got it working when I'm like running the local dev server on my computer. But the real goal is we want to have this running from here so that we don't have to run crazy dev tools. We can just point our web browser at this IP address or like set up an alias, whatever. Just point to this. It's already built. It's already ready to go. And we can control our lights, and it's awesome. So that'll also be cool because we'll talk about like what should go in a README and what should you automate when you want to have an open source project. So if you're not familiar with some of that stuff, stay tuned. It'll be really useful. So yeah, this has been Code Gets Creative. Thanks so much for watching, and I'll see you next time.